Hi everyone, and a warm welcome to this pre-summit webinar designed to bring you up to speed on what's on the horizon. I am Sofie, a member of the CloudAMQP team, and I am thrilled to be your host for today's session. Just as a quick heads up, we're here for a pre-summit webinar, and when I mention summit, I'm referring to the RabbitMQ summit, scheduled to grace Berlin on October 20. You'll find everything you need on the official RabbitMQ Summit webpage if you're seeking all the details about this summit. This page also is where you can buy the tickets to this event. With that groundwork laid, our current session is focused on RabbitMQ's potential to take the reins from outmoded message queuing solutions prevalent in legacy environments. It's a real pleasure to introduce Brett Cameron from VMS Software Inc. Before we dive into the heart of his presentation, Brett, will you please say a few words about yourself?
Thank you, Sofie. Well, firstly, thank you, Sofie, for organising the event. It's much appreciated. I had hoped, as I was saying to you earlier, I had hoped to be attending the summit in Berlin, but circumstances took hold and that wasn't possible. So it's great to have an opportunity to do this virtual event. Secondly, you're far more organised than I am, and I don't have a script about myself or anything like that. So I'll just see what I can come up with, and then we can get on with the talk. So I've been in this business, and I mean the IT business, computer industry, since 1992, and that's rather disturbing when I do the math, and that suggests I've been doing this sort of thing for 31 years now, which is in some ways depressing. But just kind of thinking about it, throughout my career, there have kind of been a couple of common threads that run through those 31 years. And those threads are really modernization and integration. And by integration, I mean message queuing. I've spent a fairly good proportion of those 31 years working with customers around the world, helping them to modernize their software environments, modernize their applications, modernize legacy applications, and so forth, often through the introduction of open source products such as RabbitMQ, helping them to integrate legacy systems with more modern open systems, and so forth. And during that time, I've worked with many middleware products, obviously RabbitMQ and numerous other ones, and we'll probably talk a little bit about some of those later on during the talk. In terms of RabbitMQ, I've been involved with RabbitMQ basically since its inception. The folks like Alexis Richardson and so forth who were responsible for the creation of RabbitMQ, I know very well. They've gone on and been successful doing other things, but they've left us with a wonderful piece of software, and also had some involvement, I suppose, on the periphery of the definition of the advanced message queuing protocol that out of which RabbitMQ evolved. So these days, as Sofie said, I work for a company called VMS Software Inc. I think I've got a slide that talks a little bit about VMS Software, or VSI as we abbreviate it, where we do actually have a legacy operating system platform, the Open VMS operating system, and we're modernizing that. We've ported it to the x86 architecture, and we have a faithful number of customers around the world that we're working with to get them across to that platform. So all in all, I'm keeping pretty busy with that and doing various bits of consulting around RabbitMQ. Thank you, Sofie.
Thank you, Brett. If any of you in the audience come up with any questions during the presentation, please feel free to add them in the Q&A section below, and we will address them afterwards. Without further ado, I'll hand over the virtual floor to Brett. The stage is all yours.
Okay, so replacing legacy message queuing solutions with RabbitMQ. What this talk is about, I suppose, is fairly self-explanatory. I'll just turn off my camera. You're probably sick of looking at me, and it might chew up some bandwidth or whatever. But the title, I suppose, is fairly self-explanatory. Message queuing has been around for a long time. There are a lot of legacy middleware products out there that customers are using. Can RabbitMQ be used to replace those products? The simple answer is yes, it can. And we'll talk a little bit about that as we go on here. And the motivation for this talk really is one particular middleware product, which I'll spend a bit of time talking about. Oops, daisy, I've broken the thing now. Sorry, Sophie. So look, we'll jump straight into it anyway. So introduction and background. Okay, so as I said at the start, look, I work for VSI, VMS Software Incorporated, and we've been around now for almost a decade. And we took over responsibility for the Open VMS operating system from HPE back in 2014, with a view to supporting Open VMS customers around the world and porting the Open VMS operating system to the x86 architecture. I'm happy to say that we have now achieved that goal, and Open VMS 9.2-1 is our first release on x86. It is alive. You can download it, play around with it if you're interested in such things. But we have a fairly large group of customers, as I say, globally, supported by 160 or so staff, support team, core engineering, and so forth, in various locations around the world. Mostly in the US and Denmark, to be honest, but people scattered elsewhere. So what is Open VMS, just very quickly before we get on to the Rabbit-related stuff? It's an operating system that's been around since the late 70s, the first version, I think, 1977, I've got there on the slide. Open VMS is a fairly proprietary operating system developed by Digital Equipment Corporation back in the day. It's not at all Unix-like, not at all Linux-like in terms of how you drive it. If you logged onto a VMS system and you're not familiar with it, you'd think you'd entered some kind of strange alien world, and none of the commands would work as you expected. But if you type help, magic would happen, and you would see how everything worked. It's a very good help system. We have, I think today, probably in excess of 1,000 customers, and the operating system is still very heavily used across all sectors, and I've listed them out there. Some good significant customers in retail and manufacturing, significant customers in healthcare, military, government, across the board. A good customer base. And as I said, we've been our sole aim in life, well, our core aim in life really has been to get the operating system running on the x86 architecture. Historically, VMS originally ran on the VAX chip, and then later on it ran on the Alpha chip, and then it ran on the Itanium chip, which was maybe not such a good move. HP are no longer manufacturing the Itanium hardware, so we've got customers kind of staring down the barrel of an end of support life for a lot of their Itanium hardware, so they're very keen for us to get x86, make that successful, and start moving across to it. So this is just kind of a timeline of the history of the operating system. And on the 5th of June 2013, my birthday, HP essentially pulled the plug on VMS, and there were a lot of frustrated customers, and this did really create some problems. But thanks to some great work by some fairly incredible people, friends of mine, and a very enthusiastic investor, we managed to set up this company and take over the support and ongoing development of the operating system. So that's kind of the background on all of that. Now on to more important matters pertaining to message queuing and such like. So I've stolen a diagram here from Alvaro's book, the first book, RabbitMQ in Action, written about RabbitMQ back in the early days, reasonably early days of RabbitMQ, I suppose. Maybe that book must have come out, I don't know, was it 2013 or something like that? Might have been the first edition. But anyway, Alvaro created this rather useful diagram, which illustrates a reasonably good chronology of message queuing systems up until the advent of RabbitMQ, the first version of Rabbit, around 2006, 2007 timeframe. As you can see from this diagram, message queuing's been around for a long time, and there are some good reasons for that. It's because it's darn useful. There was an area, I would say, where there was fairly prolific evolution of message queuing products, probably to some degree led by IBM with MQ series and so forth in the early 90s. You then had TIBCO doing their thing, and Microsoft with their MSMQ and so forth. But it was then around the mid-2000s where a gentleman named John O'Hara, who was in charge of, I think, middleware or integration at JP Chase in London, decided that, you know, all of this stuff basically need to be standardized. And we'll talk a little bit more about that in subsequent slides. And he set up this working group essentially to define the advanced message queuing protocol, out of which products like RabbitMQ evolved. So this will become a little bit more relevant as we go on. If you look at, you know, the history of message queuing and you know, what these products do, all of these products have many things in common, and they work in pretty much the same way. They provide largely the same features. I mean, you know, I'm sure you all use RabbitMQ, so you know how it works. You've got that kind of decoupling going on. You've got publishers and consumers, which are independent of one another. All message queuing products have these basic fundamental features. And, you know, the good thing about this is that publishers can kind of publish their messages and carry on doing what they do, and then consumers at their own pace within certain constraints can come in there and consume messages and do whatever they need to do. Decoupling, it's great. You know, and most of these products also provide additional features and functionality. You know, most of them will provide some additional features around scalability and fault tolerance and things like that. Capabilities such as dead letter queues and interesting bits of functionality like that. And obviously they all have client APIs. You need some way for your applications to interact with the message queuing bus, and associated with that will be some kind of wire protocol. Similarly, they all share fairly common terminology: queues, messages, routing, publishers, consumers, pub sub, point-to-point persistence. This is all common knowledge and common to all such message queuing products. And like I've said in the little yellow box there, all of those message queuing products that were on that diagram that Alvaro produced for his book, they borrowed and adapted from one another. So if you look at, you know, AMQP and so forth, as AMQP was being developed, designed, evolved, whatever, it borrowed ideas from what had gone before. It borrowed ideas from MQ, it borrowed ideas from TIBCO, and it added its own new and useful touches. It modernized some of the old ideas and added new features. Interestingly, in turn, you know, it wasn't long after RabbitMQ, for example, provided the MQTT plugin that IBM got around to also supporting MQTT within IBM's MQ. This is just natural product evolution. This is good. But there are differences between these products, and this is kind of important if you're looking at, you know, the premise of this talk or the notion of this talk that you can use RabbitMQ to replace some other legacy message queuing system. It's important to appreciate that, you know, whilst they all share certain characteristics in common, there are also some fairly interesting differences. These differences I classified as fairly basic differences. Just because they're basic doesn't mean they're trivial. I mean, they're not. I mean, different wire protocols. Okay, so that means that you can't necessarily say have MQ series interacting, but an MQ series client interacting with a TIBCO message broker. It won't work. They you know, there's an impedance mismatch. They don't speak the same language. So we've got some of these basic differences in terms of how things are done. And then you've got bigger differences where some products will do bad, evil, nasty things like content-based routing. And some products, you know, there are even kind of conceptual differences in terms of what a queue actually is and the characteristics it has. And these differences are actually, or were actually, one of the driving forces, one of the main motivations behind the advent of AMQP and RabbitMQ in the first place. So, you know, getting back to my previous comments about John O'Hara and the creation of the advanced message queuing protocol, this was born out of frustration, where he and his team at the time at JP Chase were developing integrations, and just about every integration seemed to require some new middleware product, and it didn't talk to the other middleware products. You'd have to develop gateways, and then you'd have to support the gateways, and you'd have to have people that knew how all these different products worked, and so on and so forth. And he used to refer to this as what he described as middleware hell. where you just had this pile of spaghetti and nothing to talk to anything else without you having to craft some kind of bespoke gateway or interconnector or whatever. Huge amount of time, significant cost, difficult to maintain and support. So the idea with AMQP was to avoid all of this nastiness and provide a standard that could be used universally for message queuing. Okay, so I found this old text from a presentation given by Alexis Richardson, as I say, one of the founders of Rabbit, from way back in 2008, where he commented that the AMQP working group, shared your goals, which is basically to reduce systems integration costs, compete on value add, eliminate vendor lock-in, things like that. This is what they were aiming for with the creation of products such as RabbitMQ back in the late 2000s there, when they were defining the advanced message queuing protocol. Okay, so now we'll just move on to, like I said at the start, that this talk was kind of motivated in part by I wouldn't say significant, but a moderate problem that we have with all the work we've been doing porting the Open VMS operating system to the x86 architecture. This is great. Customers are obviously very happy about this. But in addition to software that we provide for Open VMS, there are also a number of third-party products. And some of those third-party products are no longer available, no longer supported, whatever. One of those products, which I'll spend some time talking about here, is a thing called Deck Message Queue, which is an old message queuing product that Digital created many years ago for Open VMS. And if we get back to Alvaro's diagram, as somebody who's been around as long as I have, I'm getting depressed. The first thing I thought, well, one of the first things I thought when I looked at this diagram was there is something missing. And I'd mark it there in red. Around about the same time as IBM launched its MQ series message queuing product, Digital Equipment Corporation launched a product called Deck Message Queue, which was their offering in the message queuing space. And not surprisingly, Alvaro didn't include this on his diagram because he probably was not at all aware of it. And there are reasons for that, which I'll talk about on the next slide. But like I say, this product came out around about the same time as IBM's message queuing product. It was very well received by the Open VMS user community, which was very substantial back in those days, and was very heavily used in a number of sectors, particularly financial service, manufacturing. I've said the steel industry in particular. We still have a good number of customers in the steel industry that are actually using this software, telecommunications and so forth. And because of the popularity of the product, Digital ported it to various flavors of Unix and even to Windows. So it actually ended up being a pretty darn good and popular product. And just a point that I'd like to make, which is fairly relevant to this whole topic, that what you've got to keep in mind as I'm talking about all this stuff is that the applications that were written around Deck Message Queue are now 25, 30 plus years old. They've been around as long as I've been in this business. So these aren't applications that are written in Java or C# or Python or whatever. These are things that are written in old languages such as COBOL and Fortran, and if you're really lucky, they might be written in C. So we're talking about some pretty old stuff here quite often. But these applications have served the customers very well for that 25 or 30 years and continue to do so. But they're now facing problems where, the middleware product, in this case, Deck Message Queue, is potentially no longer going to be supported, or those customers want to migrate their Open VMS applications to x86, but they can't because there's no version of Message Queue for that platform. Now, like I said, Alvaro was oblivious to the existence of this product, and that's totally understandable because if any of you are familiar with the history of Digital Equipment Corporation, aside from developing very good software, something else they were very good at was poor marketing. And whilst I was preparing this talk, I did a little bit of research and dug around. I found this old kind of article or review or whatever that was reviewing the middleware products that were around in the early 90s. And that they gave Digital's message queue essentially top marks. But like they said there, no marks for marketing, good marks for excellent software, which sadly was the case for quite a few of Digital's products. Interesting that they mentioned another product in there, a thing called VCOM. That is still actually used today. I probably can't really tell you where, but it's used in the car manufacturing industry. It's kind of quite specialist to that space, but never became a kind of a mainstream message queuing solution because it's, as I say, it is somewhat specialist. If we now look at the history of DEC Message Queue, well, Digital decided to sell it along with a few other software assets to BEA Systems in the late 90s. BEA Systems in turn were acquired by Oracle in 2008. I think Oracle primarily wanted BEA's WebLogic Java-based application server, but they got Message Queue and a few other bits and pieces at the same time. There's really been virtually no advancement of the product since that time. I mean, BEA actually did quite a bit of work on it, I would have to say. That was good. But Oracle have really just kind of nursed it along. And, today there's very limited support for all platforms, not just VMS. And it will certainly not be available to customers who want to move to OpenVMS on x86, which, causes me some angst and requires a solution. So this essentially is the problem that I've found myself in, where I've got customers that want to move their OpenVMS workloads, their legacy applications, those things written in COBOL and Fortran and all other sorts of wonderful languages. They want to move them to OpenVMS on x86, but they can't because they've got message queue in there, and they're kind of stuck. What can you do? And these customers may have thought, well, maybe we could do a rip and replace, but it's expensive, it's risky, maybe different operational characteristics, and so on and so forth. So I don't like these sorts of situations. I like to think there's got to be something I can do. I like a challenge. So I put my thinking cap on and thought about this for a while, and my cunning plan, it's kind of fairly obvious, I suppose, when you think about it, is to devise, as I put here, a minimally disruptive, cost-effective, and future-proof way to replace DEC Message Queue with Rabbit. Okay, and ideally, I wanted that to be some kind of near to a drop-in replacement. Now, that's possibly delusional thinking, but it's important to aim high on these sorts of things and hopefully come somewhere close. So if we look at DEC Message Queue, and I do apologize, some of this is maybe a little bit boring, but I assure you there are some interesting snippets along the way. But essentially, the DEC Message Queuing product provides a very, very simple set of API. Well, provides a small API. I wouldn't necessarily describe the API as simple. That's not the case. It's got some obscure features, which I'll talk about. But it does provide a fairly small and concise set of functions. Right, and I've just indicated there that all of these function names, as you'll see, begin with the letters PAMS. And I was trying to find out from my colleagues what on earth this stood for, and apparently it's something like, programmable application messaging system or something like that. But the history of this stuff was that it was originally actually developed for a specific customer, and then it was productized. But anyway. There's a small set of API functions. I've listed the names of them there. Most of them seem reasonably self-explanatory in terms of their names, get message, put message, attach queue, detach queue, all the sorts of things you might expect to see. So at a high level, my cunning plan is actually very simple. Essentially implement an equivalent set of functions using the RabbitMQ C API. Okay, so we have the same function names, the same argument lists, and the same return codes. This is the goal. And if I could achieve that goal, then essentially what I have is a drop-in replacement, and I can say to customers, look, here you go. You don't need to change an ounce of your old COBOL code or Fortran code or C code or whatever. You just need to link it with this new API, and magic will happen, and everything will be good. And you're now using Rabbit instead of DEC Message Queue. How hard can it possibly be? Well, things aren't that simple, right? So there are subtle differences in the way that deck message queue does things versus the way Rabbit does things. And, whilst I'm using deck message queue as an example here, it's important to keep in mind that this is exactly the same. If you were talking about another message queuing system, if you're talking about TIBCO or MQ series or anything else that you might find out there, the differences won't be the same, but there will be some subtle differences, right? So, the same basic approach, we'll just create an API that replicates the existing one. Yes, that's fine. But you do then need to look under the hood and go, well, what are some of these subtle differences that maybe I need to take into consideration? So I'll go through some of these. I'll try and get through them fairly quickly. In terms of, routing and publishing of messages, RabbitMQ is actually, deck message queue is much simpler than Rabbit. I mean, you basically publish messages straight into a queue. There's no concept of an exchange or anything like that, or routing. You just whack straight into the queue. There it goes. It does provide a basic broadcast service. So if you think about these sorts of things in RabbitMQ terms, it's not a big deal. We could publish directly to the default exchange, which essentially goes straight into the queue. But I think maybe I wanted some more control, so we'll use a direct exchange and kind of set up the routing appropriately. And broadcast can obviously be handled using fan-out exchanges and things like that. One of the things that I'll talk about very soon that I've highlighted here is that deck message queue, rather interestingly, within the core product itself, it doesn't give queues names. Queues are identified by numbers, and they're identified by two numbers. They're identified by a thing called a group number and a thing called the queue number. And the group number, maybe you could kind of think it as being like a RabbitMQ host, but it's not really. I suppose you would kind of use the group number to group queues logically in an application context or something like that, perhaps. But the key point being that, it's not like Rabbit where you give a queue a distinct name. You identify queues by these numbers, which is, is a difference that we're going to have to contend with in terms of architecting our replacement solution. Consuming is a bit of a different story. Deck message queue does some really interesting things when it comes to consuming messages. You can consume messages based on just about any criteria you like, including examining the content of the message, which is kind of an anti-pattern as far as RabbitMQ is concerned. You can consume messages based on their priority, their type, various other attributes, and as I say, even based on content to a degree. Now, realistically, we can't handle all of this within Rabbit. It's just not going to happen. You possibly could kind of read a message and have a bit of a look at it and decide whether you liked it or not. And if you didn't like it, kind of throw it back on the queue, but then you're messing with order potentially. And you also run the risk of having a big poison message problem where you get stuck in some kind of loop. And that can be really nasty to deal with. So, after some thought and talking to some customers and so forth, it basically turned out that most customers don't really use this feature as well. And so I could largely ignore it. And this is another, I think, important factor when you're thinking about doing something like this. Don't just go and read the product manual of the product you're replacing and then try and replicate every feature. Because an interesting fact about some of these old products is, if you look at, say, something like the deck message queue manuals, there's probably like 800 pages of text, right? Nobody reads all that stuff. You would find that typically most customers would use a fraction of the available functionality. So when you are implementing these sorts of solutions, it's important to actually talk to customers about how they use the existing product and design your solution with that in mind, rather than reading through the manuals and trying to replicate faithfully every single feature, because you might be wasting a lot of time implementing features that no customer actually uses. Other differences here. So within deck message queue, there's no kind of fancy management user interface or anything like that. There are command line tools. Users can't create and destroy queues at will programmatically. Other than temporary queues. And so, our solution needs to provide some equivalent functionality. I mean, obviously, that's not difficult to achieve with Rabbit. You can impose constraints from a security perspective on what users can and can't do, obviously. And it's fairly simple to create command line tools that replicate the behavior of deck message queue. I mentioned before about queue and group numbers. These things can range from essentially 0 to 10,000, 0 to 9999. And the queue numbers have meaning. I guess this is kind of the interesting thing, that like the range of numbers from 4,000 to 6,000 for queues is reserved for broadcast queues. Okay, so essentially the fan out exchange. So if you look at the diagram at the bottom of the slide, you kind of see the pattern I've come up with here, where I'm naming queues within Rabbit, pams.queue, to identify the fact it's a queue. Well, obviously it's a queue because it shows up in the list of queues. But then the first 4 digits are the group number, second 4 digits are the actual queue number within that group. And the -DL is a dead lettering, and the -journal is a journal, which I'll talk about a little bit later on, which, as you can see, are also streams as opposed to classic queues. Note that we could use quorum queues instead of classic queues. That's largely irrelevant. A little quirk, having spent some time explaining that deck message queue uses this strange numbering system to identify queues. You can also give queues a name, but that's only used to locate queues. And the way in which we had to support that here with our little replacement solution was to implement a simple name server. So you could query the name server and say, okay, I've got a queue named Brett. What's the group and queue number associated with that particular queue? Fairly straightforward. I'll talk a little bit more about that later. As I say, queues other than broadcast or temporary queues can be journaled, right? So essentially all messages published to the queue can be written to a journal, and that's easy enough to support in RabbitMQ using streams, okay? And like I said as well, again, other than broadcast and temporary queues, all queues can have a dead letter queue, which of course is trivial as far as Rabbit is concerned. And all I really need to think about there is just what my naming convention is going to be like. So again, in the diagram here, you could see that I have a broadcast queue, which is in group 0, and the queue number is 5,000. It's not really a broadcast queue, is it? It's a fan out exchange. And so forth. So these sorts of mappings are, you don't require too much imagination to come up with how this will hang together. So I mentioned the name server, which is necessary for clients to resolve queue names and numbers, and we implemented this, very simple, using RabbitMQ's RPC mechanism. It's a small set of functions, essentially just, the ability to get queue and group numbers based on a name, to get a queue name based on number of group, registering queues, things like that. The name server, excuse the typo there, but the name server must be running for clients in order to attach to queues. So it's arguably a single point of failure, but we could make that distributed if we needed to. But essentially, you need this name server running before you can start using our replacement API. No big deal there. Connecting and disconnecting are different. In deck message queue, there's no API call to actually explicitly connect to the message bus. It's essentially all controlled by access control lists. If you have the right permissions and so forth, you can attach to the bus. The interesting thing here is that when you attach to deck message queue, your first action has to be to attach to a thing that it refers to as a primary queue. And you can attach to that by name or number. Once you've attached to that primary queue, that's an exclusive attach, which is obviously no problem for Rabbit. Once you've attached to that primary queue, you're the only person, obviously, you can use that queue. It's exclusive. You can then start attaching to other queues using other API functions and so forth. That's easy to deal with. As I say, there's no specific connect call. Just use an environment variable to convey that information to our replacement API. We did also add an additional API function to allow you to do that explicitly within your code rather than relying on the environment variable. Relatively uninteresting stuff. Disconnecting, again, there's no kind of disconnect. I mean, deck message queue doesn't have it's not really a broker architecture. I mean, you know, you don't kind of connect to it via TCP/IP and disconnect, but obviously with Rabbit you do. So essentially the PAM's exit call, which disconnects from RabbitMQ, and our replacement API, it logically just disconnects from the RabbitMQ broker and tidies up any resources that the API might be using. Nothing particularly magical there. Publishing messages. Well, publishing, there's only one function provided by deck message queue for publishing messages, but it has a fascinating array of arguments, which are listed in that table below, including many things which, you know, are in common with RabbitMQ, such as a priority, correlation ID, reply queue. And if you're familiar with developing RabbitMQ applications, these are all things you would use from time to time for various reasons. There are also a number of other arguments which don't map well to RabbitMQ header fields and so forth. So what I've tried to do there is map them to the closest possible equivalent, which has generally been very possible. Thankfully, the AMQP header fields structure is fairly rich. You can support a lot of functionality using that header mechanism. Yes, I won't bore you with all the details of that rather crazy function. Consuming messages is a little bit different. Deck message queue actually provides 3 different ways of consuming messages. It provides 2 synchronous functions. One that's immediate. There must be something there. There must be a message there. Otherwise, it will return, you know, didn't read anything. Another function which is synchronous but with a timeout, so there were no messages after, I don't know, 3 seconds or something, timeout. And there's an asynchronous one which will essentially wait forever for messages to arrive. Now, I wanted to implement a fairly common approach, which is actually fairly straightforward to do. If you think about it logically, really what deck message queue is doing is probably more akin to a get, a basic.get in RabbitMQ terms, as opposed to a basic.consume. But getting messages in Rabbit is not at all efficient compared to consuming. So I wanted to devise a common approach based around consume that I could use with all 3 of these calls. And that's not particularly difficult to do for the 2 synchronous methods. We can do that with consume fairly easily. By starting the consume and actually attach to the queue, bind to the queue, whatever terminology you want to use. And for the asynchronous one, we just spin up a separate thread, and it can just sit there and listen and wait for messages to arrive and so forth. Nothing particularly difficult. One thing that's a little bit frustrating is that deck message queue has no specific mechanism for acknowledging or not acknowledging successful processing of messages, if you like. There's no API call for that. So the best you can do here is when you do actually read a message, if you successfully read the message and everything looks good, then you basically have to do the ACK at that point, which is obviously not so great, because when the consumer application is processing a message, it might encounter some problem, and then you're kind of stuck. You would kind of prefer to be able to have control within your code over when you acknowledge the message as being successfully consumed and processed or otherwise. Unfortunately, that's not possible, but that's just the fact of life. I don't like it, but that's just the way it is. And once again, down the bottom there, as you can see, the get message calls have a fascinating list of arguments. I'll talk a little bit more about some of that later. Journals. I mentioned before that deck message queue supports this journaling feature. So every message published to a queue can conceivably be sent to a journal file. Now that's actually really easy to implement using RabbitMQ now that we have streams in there. If you look at the diagram there, you'll see that any message published to queue number 1 in group 0, essentially, we've got a journal, which is a stream that has the same routing key. So essentially, any message that's being published to that queue is also going to get dumped into the journal. That's trivial, and makes very good use of Rabbit functionality, right? And in Deck Message Queue, journals are just sequential files that with their names derived on group and queue number. Simulating that functionality, as I say, with streams is almost trivial. This functionality took me no time at all to implement. Very straightforward to do. In the API, again, to just kind of get around a few differences, we needed to use a few environment variables. I talked before about connecting and so forth to the broker. Also environment variables for default group identifier and prefetch count, right? Prefetch count is a fairly important thing, and I do a lot of RabbitMQ consulting, and it's fascinating some of the values that various people come up with for prefetch count, because they think it's going to help, and it really doesn't. But I included an environment variable for specifying a value for that default value 100. That's generally quite reasonable, I suppose. And also the environment variable for controlling timeouts on some of those message read operations. Nothing magical there. There's also one or two utility functions that Deck Message Queue provides, such as the ability to see how many messages are still in a queue, for example. And we've implemented functionality to do that, but it's not really very good. I mean, essentially, all I'm doing is doing a passive queue declare, which will return how many messages are in the queue, but that doesn't take into consideration how many messages have been delivered but unacknowledged. So, if there are such messages, you're going to get potentially inaccurate data. We might look at improving that by, maybe plugging into the management API. But I kind of not do that, because then we're building another dependency where we need to make sure that customers are using the management API, and sometimes there can be good reasons not to use it. Just very quickly, some crazy stuff that Deck Message Queue does. Originally, when Deck Message Queue was created, and this was quite common back in the early 90s and so forth, message sizes could not exceed 64K. Right, the API didn't support messages any bigger than that, and subsequently larger messages were supported. But instead of kind of modifying the arguments within the API that were used to pass in the message length and a pointer to the message, they added a couple of additional arguments to the function, which is one of the reasons why the API, the argument lists to these functions start looking a little bit lengthy. Another thing that the C programmers amongst you in the audience will spot is that every single argument is passed by reference. Even integers specifying the length of the data being published or whatever, everything's passed by reference. And at first I thought this is a little bit crazy. I mean, because it's just not good practice. But then I thought about it for a while. I thought, well, okay, this is a C API, but implementing things this way actually makes it readily possible to use that API from other languages such as Fortran and COBOL, where those languages, for example, always pass variables by default by reference, right? So that there was method in the madness. It just seems really strange when you first look at it. Why did you implement it like that? What else? We've talked about some of this with regards to the queue names and the numbers and so forth, and how consumers can select messages based on a whole myriad of different characteristics, including message content, and how we can't really address that within RabbitMQ. I mean, obviously, Rabbit does support priority queues, and you can assign a priority in message header when you publish a message, but you can't really consume based on priority. Deck Message Queue, the last point down the bottom of that slide, you can also consume or select messages based on the queue number, and that's readily handled in our API by essentially using a separate channel for each consumed queue and maintaining some relevant context within the API. So you do have to get a little bit creative here, and as I say, you do kind of have to sacrifice some functionality potentially. But for the most part, what we've come up with is a solution that is working very, very nicely. Currently working on VMS, and we're in the process of porting it across to Windows and Linux. A few things left to do, as I've listed there. Nothing of any great consequence. Documentation, you always leave that until last, of course you do. And we're in discussions with impacted customers, and by that I mean, some of our customers who are interested in moving to OpenVMS on x86 but can't because of this particular problem that I've been talking about, and they're obviously very keen on the solution. The other point that I'll make here is that getting RabbitMQ into the mix, replacing something like DECMessageQ, opens up a whole new world of integration possibilities as far as these customers are concerned, right? They've got all sorts of fun, fascinating things that they can now do from an integration perspective using Rabbit that they could never do before using a product such as DECMessageQ. So a quick summary, and then hopefully we've got some questions. First point to note, as I say, not all message queuing products are created equal. They share a lot of characteristics in common, but there are some differences. Some of those differences are trivial. Some of them are not so trivial. RabbitMQ is an excellent replacement for just about any legacy message queuing solution, I think. It offers a huge amount of flexibility. Sometimes you need to get a little bit creative, as I've had to do in this particular scenario with DECMessageQ. But generally speaking, I think the flexibility provided by Rabbit provides you with a very good opportunity, very good chance to replace pretty much any legacy product that you might find out there. And obviously there are bonuses that come from getting Rabbit in. It's non-proprietary, there's excellent support, good product roadmap, etc. And like I said before, it opens up a whole new world of possibilities for customers from an integration perspective. Like I explained earlier in the talk, the DECMessageQ product, it's not going to be around potentially for much longer. It's definitely not going to open VMS on x86, and there's very little support left. And we've got customers that require an alternative solution. Replacing it with Rabbit is a pretty good way to go, in my opinion. And obviously, it's much better if we can do that in such a way that it causes minimal disruption, right? As I say, these customers are running applications that are 20, 30 years old. They run the customer's business. Potentially they're responsible for many millions of dollars worth of business, potentially millions of dollars worth of business per minute in some cases. I kid you not. So, customers aren't going to just go rip and replace, right? They're going to think long and hard about this. So if you're going to craft some kind of replacement solution, it needs to slot in there with minimal possible disruption, minimal risk, and ideally, as few functional gaps as possible. And obviously that solution going forward must be supported, it must be supportable. And this is actually a blog post I wrote many years ago, I think 2013 or 14, about using RabbitMQ with COBOL. Key point, there's an awful lot of old stuff out there, and there's absolutely no reason why it can't utilize Rabbit. And I won't read through the words that I've kind of on that diagram down the bottom there, but there really is a lot of old stuff out there, believe me, it's quite incredible. And there's nothing wrong with it. As I say, it continues to serve the business as well. But there's potential to replace bits of that legacy environment with new products, new technologies, introduce new technologies like Rabbit to open up a whole new world of possibilities to those customers. Okay, I'm done. Thank you, Sophie.
Thank you so much, Brett, for the enlightening presentation. Well done. Now let's move on to the Q&A session. As I said before, if you have any questions, submit them in the Q&A tab down there. Let's see. Yep, here's one. How feasible do you think it would be to use this sort of approach to replace products such as IBM WebSphere MQ or TIBCO RV?
Right. So, I mentioned both those products in the talk. Fundamentally, I think, well, technically, I think it would actually be easier to replace those products with Rabbit than it would be to replace Deck Message Queue, the product that I spent most of my time talking about here. MQ series and TIBCO are probably more closely aligned with Rabbit, particularly in terms of the API structure and general operation. But one of the problems that you will face, certainly with MQ series, is it tends to be very well entrenched within an organization. If you take something like a financial services organization, there's a fairly good chance that there's an IBM mainframe in the background somewhere within that organization, and MQ will be used to exchange data with that system. MQ will be used elsewhere throughout the enterprise. So it's not kind of like you're just replacing message queuing between 2 or 3 systems with something like MQ series. It's quite often pervasive throughout an organization. So that's a much bigger problem, right? There will be a lot more resistance to change there. But technically, it's very feasible. I think it's just really the pervasiveness of something like MQ will end up being more of a challenge, not technically, but from a sales perspective, if you like, actually convincing a customer that it might be a good idea. TIBCO, I would say, probably less so in that regard. But yeah, there can be non-technical challenges. Yep.
All right, we have another one here. How effective is this bottom-up legacy support strategy comparing versus the top-down legacy strangler pattern?
Oh, that's a difficult one to answer. I suppose what I've talked about here is something of a point solution, right? We've got a very specific problem, a very specific need, and we've devised a specific solution for addressing it. If you're going to try and take some kind of top-down approach, I think that's going to be, it's a bigger equation, it's a bigger problem. There are potentially more moving parts. It's going to be a more complex sell. Yeah, it's as simple as that. I mean, it's a perfectly viable approach. There's no issue there. But I think it can be a long road to hoe, put it that way. It's going to take a while.
Thank you. Here's another one. What you have described sounds more like a solution rather than a product. How would you see this being delivered to customers?
Yep. So yes, that's fair comment. It really is a solution rather than a product, and there are a couple of reasons for that. And one of them is perhaps a little self-serving in that, well, maybe it is and maybe it isn't. But I mean, fundamentally, most of our customers will require some degree of assistance with this kind of project. If you're going to replace Deck Message Queue with RabbitMQ, they will need some help. I mean, they might need some RabbitMQ training. They might need some help, hands-on help, actually doing some of the coding work to swap out the old API and swap in the new API. So what I'm saying there is that there's a bigger opportunity than just selling the product. From my perspective, there's professional services opportunities and so forth. So as I say, that's a little bit self-serving, but ultimately we want to help the customer, and that's how we will help the customer. Okay, so yes, it is a solution. There's a product and there's a service associated with it.
Thank you. Here's another one. In the set of companies you have worked with, in percentage, how many of them use DEC message queue? Apart from x87 support, what prevent them from using RabbitMQ?
The last part of that is relatively straightforward. Absolutely nothing would really stop them from using RabbitMQ. And indeed, in my discussions with customers who are, say, still running OpenVMS on Alpha or on the Itanium platform, who have integration requirements, and they do not currently have something like Deck Message Queue, I will definitely, and somewhat obviously, advocate the use of RabbitMQ. It's a great product. So I think the second part of that question, as I say, is straightforward. There's really nothing preventing them from using RabbitMQ. And in fact, some of our customers are already using Rabbit somewhere else within their enterprise, and possibly weren't aware that they could interact with it from OpenVMS. They can do, and we can help them with that as necessary. In terms of the number of customers that are using DEC message queue, I honestly don't have an accurate answer for that. And I have some data. Some of that data is old. Anecdotally, it's going to run into the hundreds of customers. And it varies in scale. I would say probably most of those customers, to be honest, are in the manufacturing space. I said before that there's quite a few in the steel industry. I can think of several significant ones in the financial services industry. It's a significant number, and I think, if I want to look at it commercially, and maybe be a little bit crass about how I say it. There's a good commercial opportunity here for VMS Software Incorporated to help these customers. But the key point is there that we are helping, right? We're replacing something which is essentially unsupported or not even available on x86, and we're looking at replacing that with something that is arguably a better and most definitely more modern piece of software.
Thank you, Brett. We are running out of time, so we are going to wrap up this Q&A, and we would like to extend our heartfelt thanks to all of you participating in today's session. A special shout out to Brett Cameron for sharing his valuable insights and knowledge. We are so thankful for that. Last but not least, thanks to Airline Solution and as our co-organizer of this webinar. Do not forget to visit the official RabbitMQ Summit website and secure your ticket for the upcoming summit in Berlin. It's an awesome platform for continuing the learning from each other. That's all we had for today. Thank you for tuning in and have a great day.